Good morning, and welcome to this lecture of electronics. And I guess we were studying microcontrollers in the last section. We have almost completed some of the applications of microprocessors. Similarly, we have also seen some of the basic features of microcontroller and also the differences between microprocessor and microcontroller. Now, today we are going to continue with the same, and we try to find out the more conceptual or features of 8051. So let us begin with that. And for that, let me introduce myself, Dr. N.D. Mishram, Head and Associate Professor, Department of Electronics, Sri Mathura Das Mohta College of Science. And I guess my screen is visible to you. Is it visible? Yeah. So myself, Dr. N.D. Mishram, Head and Associate Professor, Department of Electronics, Sri Mathura Das Mohta College of Science. And today we are going to study more about the features of microcontroller 8051. Uh, my screen is visible to you. Is it visible? My presentation is visible. Please let me keep me updated on that. Hello, hello. Am I audible?
Yes, sir.
Yes, sir.
My screen is visible. Hello,
Yes, sir.
hello. So yes, we have studied this 8051 CPU operations, and then some of the pin diagrams we'll be studying in over there, and then the lastly we'll be concluding with the block diagram. So 8051 microcontroller, I guess we have done this, and I have just introduced 8051, referred as NCS51 in 1981. The 8051 is an 8-bit processor. We have almost completed all those things, and also 8051 became widely popular after it has been launched in the market. Some of the basic features, we have studied these features in the last lecture itself. So I guess we won't go in depth of these features now. It's just a 8-bit microprocessor, microcontroller. It is having a 8-bit processor, which says that the 8-bit of data can be processed over there, right? So these are some of the 8051 families, depending on the ROM size and RAM size. Then this is the pin diagram that we have almost completed this in the last lecture. And here we are able to see that we are having two pins, that is positive at the 40th pin, and 20th pin is the ground, right? Then we are having four ports, P0.0 to P0.7, right? 39 to 32. And we are having port 1, P1.0 to P1.7, that is from 1 to 3 up to 8. And also we are having port 2, that is P2.7 to P2.0, so 28 to 21. And similarly, the port 3, P3.0 to P3.7, right? So we are having four ports and they are being multiplexed, so they can be used in for other purposes also. So we are having this, and we'll be studying this all in depth. There is one reset terminal and then RxD, transmission data, receiving data, then uh, say interrupt 0 bar, interrupt 1 bar, then TOT1, read and write bar. Then we are having XTL2 and XTL12, that is to for the connection of the crystal. Also, we are having address latch enable, then program set enable. We will study this in depth. And then we are having A bar. So we'll be doing this all one by one. So let us begin with that. This is the basic block diagram of 8051. I guess we have completed this. I will see this. We'll also explain this in depth in the coming slides. So this is all inbuilt inside it, and this crystal and the capacitor circuit is to be connected from outside. These are the input output ports, which are actually four ports: P0, P2, P1, and P3. And yes, P0 and P2 can be say can be multiplexed and can be used as address or data latch, right? So that is the another. Then we have serial port. Then we have a timer to give it to the outside world, and it is inside. It is having 128 byte of RAM, 4 kilobyte of ROM, and we are having a interrupt control also. And this is the CPU, which is connected to all the other peripherals of the microcontroller. Okay, now separate read instructions for external data and code memory. This is some the basic concept where we require that we should have some instructions which are actually meant for the data which is kept outside the memory, outside the say the microcontroller, right? So that can be done by these instructions, and this is how it can be performed. So we are having an internal code memory, that is ROM or EEPROM. ROM means read-only memory, where already some of the instructions are being uh, stored to initialize the microcontroller in the starting as soon as the power is on, right? So we require some of the instructions to be done by that microcontroller itself. So that is being all kept in this, say, in this internal code memory. Then we are having external data memory RAM, which is around 64 kilobyte. Now this is external, so it can be used externally also. Inside also we are having that. So we are having external code memory ROM or EEPROM, uh, right, of about 64 kilobytes. So that can be attached to it, to the microcontroller. Now, this is the situation of the internal data memory, in which initially register banks are there, R0 to R7, and register bank 1, register bank 2, register bank 3. In all, many registers are there. In microprocessor, we were having only 7 general purpose registers. Now here we are having banks of these registers, so they can be used as per our requirement. Then we are having a 16 bytes of 8-bit RAM. Then we are having general purpose RAM, that is variable RAM. Then SFR direct access, 128 bytes of say memory again to store the data. So we are having this internal structure itself and some external memory which is to be connected to the microcontroller. Now let us begin with the pin description of 8051, right? What we have studied there. So one by one we'll study that. So 8051 family members, that is 8751, 89C51, 89C52, and in that case BS 89C44, 4x0. So these are the families of 8051. Now all are having a 40 pins dedicated for various functions such as input, output, read, write, address, data, and interrupts. So all these ICs are having a 14-pin dual inline package. Dual inline package means it has having pins on both the sides. So we are having dual inline package. Then we have it comes in different packages also, such as dual inline package, then quad flat package means in square, and also in leadless chip carrier. So we can have that also. Then some companies provide 20-pin versions of 8051 with reduced number of input output ports for less demanding applications. So where we require only 20 or 2 ports, 2 output input ports, so we can go for these 20-pin packages also. Now, some of the memory pins, some of the pins that we need to study, we are starting from XTL1 to XTL2, which is actually pin number 19 and 18, if you have seen in the block diagram, sorry, in the pin diagram of that. So here, yeah, so here it is placed in pin number 18 and 19, so XTL2 and XTL1. Now here it has been connected for, say, uh, the crystal, right? So it has been the crystal is connected outside, and this is connected with respect to two capacitors, that is around 30 picofarad, and it is connected to the ground. And these are the XTL2 and XTL1 pin, and this is the external circuit that we are supposed to connect with the microcontroller, right? So a quad crystal oscillator is connected to inputs XTL1 and pin number 19 and pin number 18. The quartz crystal oscillator also needs two capacitors of 30 picofarad value, and the original 8051 operates at 12 megahertz frequency, right? So we require to generate a 12 megahertz of frequency by using this crystal oscillator circuit, and which is being fed to this say microcontroller by this pin number 19 and pin number 80. Okay, and this, if you use a frequency source other than crystal oscillator such as TTL oscillator, it will be connected to XTL1 and XTL2 is left. So only one can be connected and the other is left. So if you are using a single oscillator, TTL oscillator circuit, instead of uh, say quartz crystal, so we can use only one terminal, that is XTL1, and the other is not connected, right? Like this. So only XTL1 is to be given. That TTL means transistor logic oscillators that can be used over here. And instead of using the crystal oscillator, if you are using the crystal oscillator, then both the terminals are should be used, right? So one by one, and this is a ground. So this is the two pins that is for the connection of say the crystal oscillator, and then reset pin is an input and is active high, normally low, right? So it is active high means whenever we give high, then only it will be active, and normally it is low means if that pin is kept open, it implies that it is low, right? So upon applying a high pulse to this pin, the microcontroller will reset and terminate all activity. So we have a reset pin. I have shown you that in the kit, that it is having a switch which is connected to positive supply. As soon as we press that is push to on switch, uh, all the programs or all the data is there in the microcontroller will be reset. So it will reset all its data and then it will start again. This is often referred to as a power on reset. So it is actually as good as a power on reset. Then activating a power on reset will cause all values in the registers to be lost. So as we have said that in microprocessor also, if we switch off the power supply, then all the data which is being stored in the general purpose registers, that goes out, right? So the same situation is there in this microcontroller. We have a reset button. As soon as we push this reset button to high level, then automatically all the data that is being kept in registers has to be lost. So this is the concept of that. So reset value of some 8051 registers. So what happens when we press a reset key? So the program counter automatically switches to 000, right? So it will shift to the program counter means where the program is being kept. So the address of that, uh, say address of that memory location where the program is starting, so that now resets to 000. So this is what happens when we put a reset. Then DPTR, that is another register which is also being zero. Then accumulator becomes zero. Program status word, that are flags, those also become zero. Then we have a stack pointer that lands on point 7 07, and uh, S B register B is also there, so that is also 00. And port 0 to port 3, they will change to FF. So all will show you, and if all the four ports are going to show you output as FF. So this is what happens when we put just press a reset key on which is active high, right? Then we have address external access, that is EA, is an input pin and must be connected to VCC or ground, right? Now this 8051 family members all come with on-chip ROM to store programs, and also have an external code and data memory, right? So we are having on-chip ROM, and if we want that the access is given to the outside, right? So this external access can be used, right? Normally EA pin is connected to plus VCC, that is we are having an internal access. So if it is kept high, or if it is kept open, then the chip considers it as high, and say it will consider that we are not accessing the outside memory, right? So to access the outside memory, we have to give this EA external access as high, right? So normally EA pin is kept connected to plus VCC, that is for internal access. Now EA pin must be connected to ground to indicate that the code or data is stored externally. So when we are using this data, or say data, or say some uh, say component that is stored outside the memory of the microcontroller, then this EA should be given low. So this terminal is actually active low terminal. And then we are having this PSN and ALE. PSN means program store enable, right? Is an output pin. Then this pin is connected to OE pin of the external memory. And for external code memory, program state store enable will be equal to 0. For external code memory means when we are supposed to use the external memory, this PSN should remain at 0 or ground. For external data memory, this program store enable will be is supposed to become high. That is one. And ALE, that is address slash enable pin, is used for demultiplexing the address and data bus. This is similar to what we have used in microprocessor. So we were also using the microprocessor. Uh, this multiplexing technique, address latch enable, where we are using the same lines for data and the same lines are being used for the address, right? So that is also there in this section, and we are having this ALE also in microcontrollers too. So we are having this pin PSEN, that is program store enable, and say address latch enable. So this is again active low. So if this pin is external, if we want to give uh, external access, then this is low, and if it is sorry, yeah, for external data memory, it should be high, and for external code memory, it should be zero. Then input output ports. Now, this is the main important portion of say 8051. That is the more applications we are having around four ports in microcontroller 8051. So as you can see, we are having P0.0 to P0.7. This is the port 0, and then we are having P1 to P1.0 to P1.8. These are specifically for say the outputs and inputs. So P0 and P1, then we are having P2.7 to P2.0. This is third port, and P3.0 to P3.7. That is the fourth port. So in all, we are having four ports in 8051 or 8031 microcontrollers, and the four 8-bit input output ports P0, P1, P2, and P3 each uses 8 pins. Right now, these pins, all the ports upon a reset are configured as output, ready to be used as input ports by external device. Right. So these are used as output port, means the data is to be fed out. Right. As soon as we press the reset button, that implies that this output port can work as an input for the other devices which are connected across these outputs. Right. So these are the input output ports. Then one by one we'll see all the ports. So port 0. So port 0 is also designated as AD0 to AD7. Now, what is AD0 to AD7 means? It is being connected to address, as well as it is used to take the data, read the data, or write the data in the microcontroller, right? So this P0.0 to P0.7 is basically used for two purposes. When we are using it outside, when we are programming it, right? This uh, port P0.0 to P0.7 can be used for data as well as the lower order address bus. Address bus means they are being multiplexed. So they can be used to give the address of the data, or they can use for taking the data, reading the data from say the external programmer or anything. That can be done. So this port has a multiplexing. When connecting an 8051 to an external memory, port 0 provides both address and data. Then 8051 multiplexes address and data through port 0 to save pins. So we would not be requiring other pins, 8 pins for this data and address. So we have reduced that by using same port for address and data, right? And we are having the address latch enable indicates if P0 has address or data. So ALE, I have shown you in the last pin that ALE is the pin which is actually enabling whether this port is being used for address, or it is being this port is used for address, or it is being used as to take the data, receive the data, or transfer the data, right? So this is the port 0. Then when ALE is 0, it provides data D0 to D7. Similarly, when ALE is 1, it has address A0 to A7. So lower order address bits are being stored over here in this port, right? So do you understand this, what I mean to say? When we are supposed to program this IC, when we want that this it should be programmed, right? So for that programming, we have to feed that program in this microcontroller, right? And at that time, we require some ports or some lines which can be used for address, as well as the data to be stored inside the microcontroller. That time we require this port 0, and this port 0 are being multiplexed. Port 0 is being multiplexed for using address as well as the data. So when this address latch enable is 0, it provides the data, means it can be used to store the data, receive the data, or say it can be also used to write the data in the external memory. So all can be done over there. So basically they are being used for taking the data from the programmer, right? So from the kit of program. And when we have programmed it all together, now this port 0 will exclusively used as an input or output port. Now then it won't be used, it will not be using as an address or data line. So when we have programmed it, so for programming purpose, this can be used for 80 to 87, or and otherwise when we are putting it to that special device and for special purpose, this is simple a port which can be used as an input port, and similarly it can be used as an output port. So both can be used in that case. So this port 0 is a very important port as far as programming is concerned. And then port 1 and port 2. So these are port 1 is from pin number 1 to pin number 8, P1.0 to P1.7. And port 2 is from P2.0 to P2.7. Now, as you can see that this P1.0 to P1.7 is a simple port and it is not designated to any other functions. Now, this is a simplest port that we are having, and it can be used as an input or output port to send the data or to receive the data from the external devices. So it is the simple port, right? So 8051 based system with no external memory connection, both P1 and P2 are used as simple input output ports. And 8051 based system with external memory connections. Now in this case, we can use this port 2 must be used along with port 0 to provide the 16-bit address for external memory. As I've told you, the P0.1 to P0.7 is used as, say, address data multiplex address data lines, right? So by using that address data line and this lower address lines above and higher address lines over here, so they can be multiplexed, right? And they can be used. So port 0 provides the lower 8 bits via A0 to A7, as I've told you in the earlier slide, whereas these ports from P20 to P2.7, they provide the higher order address bus, right? So P2 is used for the upper 8 bits of 16-bit address designated as A8 to A15, and that it cannot be used for input output. Now, when we are programming it, when we are using it as to feed the program from, say, the programmer to this IC, then this port 2 can be used as a upper higher address bus, right? So it starts from A8 to A15, and lower can be used from port 0, as I've told you in the earlier slide. Whereas port 1 is the simplest input output port, which is only used for inputting or outputting the data when it is being absolutely programmed. I guess you have understood this. Then we have having a port 3. So port 3 can be used as input or output port. Simple. It is the ports can be used for input and output port as per the requirement. But along with that, port 3 has an additional function of providing some extremely important signals, right? Uh, they are these pins. So we are having this receive and transmit, that is pin number 10 and 11. This is P3.0 to P3.1. This is for serial communication. So receiving the data and transmission of data, uh, see RxD and TxD, those are pin number 10 and 11. Then we are having external interrupts, that is interrupt 0 and interrupt 1, that is P3.2 and P3.3, pin number 12 and 13. Then we are having P3.4 to P3.5, that is T0 and T1, that those are the timers, right? And then P3.6 to P3.7, those are being used for bar and read bar and write bar. Write bar means whenever this terminal goes low, the device, the microcontroller is supposed to write something, means to write the data outside or write the data inside. Similarly, when we are reading this, so this pin number 7, that is P3.7, can be used to read the data. Read the data means take the data from the external device. right? So read write signals for of external memory. So we can read the data as well as at the same time we can write the data in the external memories if these terminals are used for those. So this is again port 3 is again multi-dimension, multifaceted, so that it can be used for say the other things. But or and otherwise, when we have programmed this microcontroller, we are using it as a simple input output ports, right? So these are some of the ports, and then we'll conclude with some of the pin configurations. I guess we'll continue this in the next lecture. And what we have studied today are some of the pin configurations of 8051. These are the pin configurations that we are expecting to study today. And this is the block diagram of 8051. We'll study this in depth in the coming slides. And we are having separate instructions for external data and external code memories, which are kept outside the microcontroller. Then pin description of 8051. 8051 family is having a 40 pin dual inline package. We are having some more package, that is quad flat package and leadless chip carrier. We are having this some pins which are having not no leads, which are having some points, right? In dual line package, we are having pins coming out of the IC as shown over here. So I guess that is the first slide. Yeah, so as you can see over here, this is the 8051 IC, and they are having pins. So dual inline package means they are having pins on both the sides, right? So that is dual inline package. Whereas leadless means we are having just a point which is coming out of it and which can be put on something and which gets attached to that particular point. So that is the importance of leadless package. So we have studied this, and then uh, yes, we have completed this. And some companies also have 20 pin packages, and these are the two pins 19 and 18 which can be used for to connect the clock. And for that we can use a crystal, quartz crystal with 30 picofarad 30 picofarad capacitors to provide around 12 megahertz of frequency. Then we are also, if you are using, say, also, if you are using a TTL oscillator, then only the XTL1 pin is connected, rest of the pin is being ground. So this is the connection. I have shown you this. Then the reset terminal, the importance of reset terminal, what happens when we put a reset. So all the data is being reset and the register becomes 00, whereas the output are expected to give the output. Now these are some of the conditions. Then we have external access, right? I have told you about this. Then this is program store enable, PSN, and address latch enable. Address latch enable is for port 0, where we can use that 8 lines for port as well as they can use for data. So these are the four 8-bit ports, P0, P1, P2, and P3. Each uses 8 pins. Then port 0, which can be multiplexed to use as data as well as for address, which is being, say, commanded by address latch enable. If it is 0, then it provides to use data D0 to D7, whereas when it is high address latch enable, then it is used for the lower order address bus. Then port 1 and port 2. So port 2 is again multiplexed for a higher order address bus, A8 to A15, and generally it can be used outside the programming. It can be used as a simple input output. Similarly, port 3. So these are some of the basic functions of port 3 other than used as input output port. So when we have been programming this microcontroller, we'll be using this pins for that. So I guess this much is enough for today. If you have any queries, you can ask me now. Hello. Thank you for joining this class, and I will be uploading more videos on my YouTube channel. Please go through my YouTube channel, like, share, and subscribe. Thank you very much. By that time, stay home, stay safe, take care. See you in the next class. Bye. Good day. See you.